All right, so in this video, we're going to be looking at an input-output system. Now, there are different kinds of input-output problems. Some of them just have two sectors or three sectors that interact with each other but don't have any external demands. There are other versions of these problems that do have external demands. In this case, we're only going to be looking at the situation where there are no external demands. It's just the systems relying on each other. So let's look at our problem. So suppose an economy has only two sectors, goods and services. Each year, goods sells 85% of its output to services and keeps the rest, while services sells 65% of its output to goods and retains the rest. Find the equilibrium price for the annual outputs of goods and services that make each sector's income match its expenditures. So since goods sells 85% of its output to services, we have goods selling to services here 85%, and services selling to goods at 65%. Now, since the problem says that goods sells 85% to services, we know that the remaining 15% stays with goods. So we can fill that part of the table in because we know that everything that goods sells has to be 100%. It can't be more or less than that in order to account for everything in the system. And then we do the same thing for the services column. Since 65% is sold to goods, that means that it retains 35% of its own services to maintain those services. So we have 65 and 35. We can now represent this table as an equation. So on the one side of the equation, we have goods and services, and they cycle through each other by 15% coming back to goods and 65% coming from services. And then same thing, we have services gets 85% from goods and 35% from services. So notice that this right side of the system of equations here are just the coefficients that we pulled out of our table. Now, in this case, again, we have no constant, so we can just go ahead and solve the system. Now, I'm not sure why these variables changed, but we'll fix them. So we return this into a matrix equation. Now, on the goods and services side, we don't want this per se in the form of a vector because we need to be able to subtract this from the matrix and in order to put all of our goods and services information in the same place. So I'm going to multiply by my goods and services vector by the identity matrix. And then on the other side, my standard coefficient matrix will match up goods in the first column, services in the second column. Now, if we then move everything to one side of the equation, we can then do matrix arithmetic and combine our matrices together by subtracting, in this case, corresponding components. And that is going to leave us with the goods and services vector standing by itself. We can factor that out because it's multiplying both of these matrices. And then if we combine corresponding components, we end up with a matrix that has these coefficients. And the other side of the equation, of course, is now 0. So the system is homogeneous. Now, because the system is homogeneous, what we're looking for are dependent solutions. And we can see that the two rows of our matrix are dependent on each other. There are multiples of each other. This is just the negative of the one at the top. So we take one of the equations, whichever one you want, and solve for our variables. So remember, first column is G, second column is S. for whatever reason. So our top equation, 0.85g minus 0.65s, that's equal to 0. And so we move the s to the other side of the equation, and then we divide by the 0.85. And what we end up with is g is 13/17 of s. When you simplify 0.85 over 0.65 over 0.85, this is 13 times 5, and this is 17 times 5. So you end up with 13 over 17. So this is, again, it's a vector. So whenever services are $17,000, goods will be $13,000, or any scalar multiple of this relationship. So this kind of a problem, when there is not an external constraint on the system, it's not going to be an exact solution. All you're going to have is a ratio, because proportions of goods and services are going into each other. And so as long as they maintain that correct proportion, the system will function fine, but they can scale up or down relative to each other as long as they scale together.